All right. Good evening, guys. Hope everyone has settled down. Thank you. Thank you so much for joining, and I welcome everyone on behalf of the user group meetup. This is the 19th one, and we are really excited for some good conversations today. Let me first get through the introduction slides, and without wasting further ado, I'll head over mic to my speakers. Thanks a lot to the sponsors, AWS, for this venue. And a little housekeeping note, please be mindful of your belongings and please do not forget it while you leave the place. A little about the footprint the user group is treading. We are running across the globe, multiple countries, and we recently started this chapter in India as well. And so far, we have got very fruitful results for the same. There are some QR codes. If you are willing to speak, share your experience, feel free to sign up from the form. If you're looking for volunteers, speaking, sponsorships, we are all in. We want to hear more from you. And please do follow us on the social networks as well and share the feedback of whatever opinions you have or any improvements we could do for these events. We are all ears. We take the feedbacks very seriously. So a little brief about today's topics. We have two topics, basically, one from Ashish, who will be speaking about AI and Kubernetes introduction. And then we have a discussion around Cilium with EKS from none other than Lee from Isovalent. And before moving forward, I have a quick announcement from Leonardo as well from MongoDB. So please.
Thank you, Pajan, for the space. Hello, everybody. My name is Leonardo. I co-organize the Toronto MongoDB user group meetups, and we're here today sharing a discount coupon for a conference. That's the MongoDB Local Toronto. That's going to be on Tuesday. It's the 15th of April. It's a full-day event. You have the website with the agenda and all the details. And the full price is $100, but with the coupon, you get 60% off. So please, if you're willing to attend, check the link and take a picture, take a note of the coupon to be used. It's a full day event, as I said, and the food and beverage and everything is included. It's going to happen in the Benfield Center, where they have the CNE. So it's nearby. There are a lot of public transportation available. Thank you very much.
Thank you.
Thank you. Hi, I'm Ashish. I hope some of you guys know me. So I'm going to present something related to Kubernetes and AI. So basically, as AI is growing, we like how Kubernetes helps and what kind of tooling is being developed. Again, it's not a full-fledged thing here. It's more like an introduction. So many of you might know it, and if you don't know it, I'm going to give a kind of a demo example, and it's going to be a quick talk. Again, this is me. First of all, like what is AI? AI is exactly like manipulations of data, or like we are learning from data, which is known as like learning patterns. How Kubernetes helps, I think if everyone uses Kubernetes in the daily life or not. Okay, some of you guys. So Kubernetes basically helps us to scale well in any case, like based on resources, based on usage, there are multiple tools where you can scale well. There are multiple resources in Kubernetes, which helps in scaling of the things. So for example, AI challenges are like how we do large data processing. So Kubernetes helps in like distributed computing there. Similarly, like hardware GPUs. So Kubernetes helps us in allocating smart resources. Reproducibility issues, containerization definitely helps there. Deployment complexities, there are tools are being built in Kubernetes now, which helps in like finalizing or streamlining the pipelines. Some of the tools example like Kubeflow is a open source, again, AI ML framework. TensorFlow, MLflow, KF serving, and NVIDIA GPU operator. So basically all these works with Kubernetes. So if someone is really looking for doing AI model scaling, they can use these tools. Again, all the documentation and everything is there. Again, every tool is kind of a different topic to learn, but you can use it in a simple scenario. So I'll use it maybe in a demo part. I'll show you guys something. Again, how the steps involves, like we train a model. So I'm not going to train a model here. To be very fair, I'm just going to download a model and use it. Again, how we do that is typically we convert the model into Docker container, and then we can deploy and auto scale. Steps, typically, like, for example, I mentioned here, prepare your AI model. So what AI model you want to use depends on that. So every model has its own aspects. Today, which I'm going to use is kind of a Whisper from OpenAI, which is typically do a transcription, which is basically sound to text. So there is a Docker file we need to create. There is a Kubernetes YAML. Then we can test our deployments, scale the deployments. Again, these are Kubernetes feature. These are not ML model feature. So we can definitely scale things based on these things. Kind of a demo. So let's see the screen, right? Okay. So this is, again, I'll cover some of the things here. For example, this is my Python code. Again, it's not doing anything. It's just opening a endpoint, which is transcribe. I have kind of a Docker file. Again, you will see I'm installing this. FFmpeg is basically a plugin or a extension used for OpenAI Whisper. So I'm using OpenAI Torch and Flask. Again, copying the small code here and then running it. So personally, anyone can do this and anyone can learn this thing out. It's very easy to test those things out. So again, I have a requirement file. Like, again, what I'm gonna do is, like, I already ran this so that it's not, I don't need to download it, and maybe I'll just zoom it up. It's easy readable, right? Okay, so again, I'm using Podman. Again, this is some restrictions to me. I can't use Docker, but Podman is kind of a Docker open source. So I built a image already. You will see only the copying steps happening here. Again, this is the same Docker file. I am in the same demo project, and we're going to run the same model. Oops. Oh, seems like my Podman machine died. Okay, I think it will take some time for me to figure out the region, but if you do it, and then basically if we can, maybe it's running already. Let me try again. Some things. If this helps. So basically, I'm just trying to, so how Podman runs is in the background, it's create a virtual machine behind the scenes and run everything in that. Not really sure what happens before, but I'm just trying to reset it out. If it works, then I can show you guys. But otherwise, typically the Docker container you can run, and then it's a Flask endpoint, 5000. And if you submit an audio file there, it will transcribe it as a text. So it's pretty simple, which is, again, I'm not training any model here. I'm not doing any, I downloaded a public availability of Whisper model, and then you can use it. So my point here is basically to start with AI is pretty simple. So anyone can do that and anyone can start learning. Again, I'm presenting this because there are some people in this meetup they approach me and they're like, oh, we can't really start it out, like how to start doing the model testing or at least using it. So this is kind of an intro to that. Most probably it will take just 1 more minute. Sure.
So you have the image size of 875 meg,
That's a Podman default image, yeah.
but are you packaging the model artifact into the container?
Yes, right now it's inside. So if you look at the Docker file, so you will see this Whisper install. So this is basically the model. Let's see if
So you had this method and fact
Yeah.
transcribe, transcode a file, and what model is doing?
model is basically transversing your audio file to text. Let's see, hope it works now.
You're using an OpenAI model, right?
Yes, OpenAI
Or-
Whisper.
That's free or?
OpenAI Whisper is free.
With the command or? What's the minimum specifications to run that model?
I have not checked yet. I think my virtual machine is 10 GB hard disk, 2 CPU. That's all I'm running right now. So you may need to travel it. So my phone. So again, commercial perspective, I don't know. Maybe need to check the licensing stuff, but definitely starting point, we can definitely do that. This time it works. Anyone wants to record something? Who is good in English? Anyone? You wanna try? Come. If it works, then we can try doing the same. Okay. Looks like it worked this time. So what I'm gonna do is I'm gonna create a voice note. Anyone wanna try speaking something? No? Come. I think you need to come near laptop's mic. Let's see how good this model is.
Can say anything?
In English, please. I think you can just speak.
Okay. Hello from Toronto, Canada.
That's all.
Oh,
Okay, let's see. This works. I'm just copying it in my project because I'm referring my URL there. Now this is running in my, so I can actually send here. Demo. You will see whatever the guy speaks. So hello from Toronto, Canada. So it's a direct translation from voice to text. Again, I'm running this model locally. Again, we can run the same in Kubernetes using the Kubernetes services and demo files. And again, because Kubernetes helps in scaling, like using KEDA and so many autoscalers there. So we can extend this model and like use it with any number of resources. Yep, that's all on my side. Thank you very much. So next presenter, Lihi, basically. You want to present?
Is that my turn?
Yes.
I thought you were- you asked some questions.
Sure, go ahead. So again, a simple example will be like writing a kind of a service and a deployment file. Again, deployment scales itself and service will talk to deployment. It's a kind of a dummy example here. Because I'm running in the pod, I'm running a Flask application, so it will be running any Flask application.
Using those frameworks that you mentioned on the first slide, the ML flow, those kind of frameworks.
So those are the tools to run this thing also. So I'm not explaining those tools. I'm just giving a kind of a basic introduction, how you run a model or how you can actually start with even AI in your local computer or something. So definitely those tools helps in a very different way to do the things. Like for example, KF serving is used for model serving. Then there are ML flow helps you in even training side of things. Okay, I forgot to mention one more thing. I think there, this one, sorry, this one. So there are something. So from where I inspired this thing is typically there is this paper from CNCF group, which definitely you can see or read like it's a public paper. This paper corresponds to these many tools. So for example, distributed training, what are the tools Kubernetes launched? Sorry, CNCF supports or launch or there are in incubation. There are model LLM observability tools, vector DBs. So these are kind of all the tools to do one step. So anyone can do or pick or start learning these tools. The other thing is recently, I'm not really sure if anyone's seen this. There's a new Kubernetes group, which is JobSet. So JobSet is helping now. This is kind of a new object type in Kubernetes, which will help in basically running the jobs or replicated jobs in for the training where Kubernetes was lacking. So this is pretty new concepts. You might not see like a kubectl get pods versus kubectl get job sets. So this is kind of very new right now. So definitely there are things moving ahead and you will see like just a kind of again demo thing. So you will see here, it's being roadmapped to like PyTorch, some of the new tools here, MultiQ. So they are integrating this in future. So you will see this thing being used in at least on the training side of ML services. Yep, that's all on me. Sorry, yes, please go ahead.
So like when we run traditional workloads, like when we Kubernetes cluster with ordinary nodes, right? There are no GPUs on them.
Right.
GPUs are expensive. And then if you would like to run something that needs GPU, then I assume like we usually create another node with GPU, and then we need to mark our pods deployment somehow to run with a specific node.
So
What would be the best practice to kind of architect this like use this marking?
okay, so definitely the marking happens based on affinity. So in Kubernetes, there is a concept called affinity. You can define, for example, you define a node group there or a node pool. You define there and those nodes, those pods will be created in those nodes. The first step where you are saying you are not using GPU and GPUs are expensive. So KEDA helps from 0 to top. So KEDA is an autoscaler. Basically, if you install KEDA and you configure it well, it can work on your queue size. So for example, your requests are coming in a queue. If you see there is no requests, it can scale down nodes to 0. But if there are queue messages, it will scale up to consider one node first. And then again, this scaling up always takes time based on, I'll say the cloud provider, right? GPU nodes are scaling. If I'm not wrong, last time I tried, it was taking like 5 to 6 minutes for me. So if otherwise you can always use one running and scale up when needed. So that's also you can configure it. That's what I can think of.
Can we use KEDA on AWS? Or
Yeah, anywhere, any Kubernetes cluster. Because AWS, I think AWS support natively KEDA too. There is, I'm pretty sure Azure do that. So you can have an extra plugin, just need to check mark. So you can install KEDA like in any Kubernetes cluster. Sorry, you're saying something.
No, this is actually also an answer Igor's question. The problem with spinning GPU nodes normally that takes a long time, and GPUs are expensive, like you said.
Absolutely.
And they are, well, it's a bit depending on the vendor, but let's talk for a second about NVIDIA, which is, I don't know how much market share they have, 80% or so. There are about 6 different ways to do GPU sharing. And some of them play better with Kubernetes clusters, some plays less nice, and you have a new feature in Kubernetes called DRA, Dynamic Resource Allocation, which was released beta in 132, I believe, like latest. It's in beta, but that will also allow you to, not to say, okay, I have one workload that needs GPU, then give it the whole GPU because maybe it makes like 10% of it or so, or a fraction of it. So there are quite a bit of work also on the Kubernetes side, but
yeah, maybe I have not read it about like DRA yet. Maybe soon. I'm also learning AI right now. I'm a Kubernetes guy. I'm a SRE by profession. So I'm working in cloud like last 7-8 years, to be very fair. So yeah, I'm also learning. So it's again a bit of introduction, so anyone can try it out. I think it's pretty clear right now. It transcribes voice in front. So yeah. Yep, I think any more questions? Yes, no. I'll be here. We can talk later. Let's listen to the second presenter. Who's coming? Thank you. Will you join too?
Yeah, I just.
Today I'm gonna talk a little bit about Scylla and how Scylla can be the Swiss Army knife on EKS. So this is gonna be today's agenda. And first, we will have a very brief introduction for Cilium, eBPF. Then we'll talk about how Cilium work with EKS. And then we will dive into how to use Cilium as a Swiss Army knife in the EKS environment. And then we'll have a kind of a demo to see how it works. In the last, we'll get to the Q&A session. So first, I would like to know how many of you heard about Cilium or even using about Cilium? Oh, that's quite a lot. Okay. So actually, Cilium is an open source project, and it's an open source project on the Kubernetes for networking primarily. And I'm from Isovalent. Isovalent is the company behind the Cilium project. Right now, it's part of Cisco, and Isovalent provides the Cilium Enterprise. So first, what is Cilium? And the Cilium basically is providing the networking for Kubernetes. And on top of the networking, like basic networking, it also provides the networking security and also observabilities. However, if we look at the Cilium under the hook, it's using a new Linux kernel technology called eBPF. You may ask what the eBPF really is. So the eBPF is like a JavaScript browser for the kernel. Think about it, like you can attach your program to the kernel and let the kernel to run your logic on certain hooks. For example, like this one, when some process is executing some syscall, you can have your eBPF program to receive this syscall, and in this case, you can, doing some observability or, knowing how many syscall this process is doing or even blocking it. You may ask, like, why this is anything to do with like networking. So the very common use case in eBPF for Linux networking is improve the performance. On the left, you can see usually like when the traffic leaves the Kubernetes pod, it goes through the networking stack. Like it can be the Linux IP tables or other stuff. Like on the right side, you can see when you have the eBPF in the Linux kernel, actually you can utilize your code to bypass a lot of like a Linux stack. That's kind of very common use case with the eBPF. Okay, so Cilium has been adopted by a lot of companies. As you can see here, they are all from different industry like AWS, Bell, and Capital One, and Google, and all the industries Oh, by the way, you can interrupt me anytime if you have any questions, because something like, I'm gonna go through a very basic level and maybe something you would like to know a little bit more, you can just interrupt me at that slide. I will try to explain if I can. Okay, so we talk a little bit about eBPF, Cilium. Let's talk about Cilium on EKS. So from our data, we can see EKS is our biggest Kubernetes platform for the Cilium user. And on EKS, we have two models of support. The first one is called chain model, which means that AWS, like when you spin up the Kubernetes, you usually have a AWS CNI dealing with your networking. And in the chaining model, actually, the Cilium will chaining with the AWS CNI. That means your AWS CNI are still doing the basic networking, like the left one showing. And Cilium is doing more advanced stuff. It can be network policy or load balancing or observabilities. It's easier to start because you don't have to replace or delete your AWS CNI, and you can have your Cilium on top of your AWS CNI. However, it has some costs. We'll talk about that later. And another model is actually called the ENI model, which is the one we're seeing on the right side. In that model, actually, Cilium gonna take care of everything. You will need to delete your AWS CNI, and Cilium will try to talk with the AWS API to take care of the networking, everything for you. This is actually preferred model because usually in the networking world, like if there are two CNI, they can conflict with each other, especially when you use some advanced Cilium features, and that only works with the ENI. And in this demo, we're gonna use the ENI, but this is like the basic model that you can have on EKS, like two models, but ENI is the preferred. And here are some, I assume there are some common requirements on EKS, like let's go through that. So first, I'm gonna assume you probably need to do some canary deployment for your application on the EKS. Maybe it's at the ingress level or even at the east-west traffic. And let's see how we can do that. How can we do that with Cilium? The second requirement, I'm assuming you may have the requirements that you need to encrypt the traffic when the traffic leaves the pods on the networking to be in compliance with the regulation. For example, a very common one can be the PCI DSS, where they ask you to encrypt the traffic when they are on the networking. And usually on top of the encryption, and a lot of people are gonna try to implement the zero trust networking, where you only give the list of permission, a list of privilege permission to the pods. We'll talk about how we can do that without Cilium, then we can try to see how that works with Cilium. Last, when all this networking happening, like how can you do the troubleshooting? And we'll check that how it works without and with Cilium. So let's look at the first one. How I can do my canary deployment for my app on EKS. Usually the very common answer is Nginx or traffic. And let's see what we usually can do with Cilium for this kind of requirements. Before going into that, I'm not sure. Can you see the screen? Okay. So on the right of the screen, you can see it's a very common ingress object. And a lot of people are using that for the ingress to route their traffic from external to the internal. The ingress object is a Kubernetes standard object, however, it has its own problem. For example, the most common one is how can you do that for non-HTTP or non-HTTPS traffic? And you can see there are a lot of annotation just to work with the ingress. Like when you move things around, changing one ingress to another, how do I deal with those annotation? And how can I do more advanced routing? For example, if I would like to do the routing based on the HTTP header, how can I do that? And the last but not the least is, it's very common that different teams are responsible for different things. Like in this model, how can platform engineer or developers manage different things? For example, like usually platform engineer dealing with the ingress itself, and the app developer may decide like I want to manage the application for certain routes. So the successor of the ingress actually is the Cloud Gateway API. On the left side, you can see that right now it has different resources like gateway class, gateway, and the TLS route or the HTTP route. The concept is very simple. Like the infrastructure or the platform engineer will start to manage the gateway class and the gateway and let the developer to manage the TLS route. And from here, you can also see that it does not only support the HTTP, it actually can also do the non-HTTP routes. And on the right side, actually, is a kind of a demonstration showing you that you can use Cilium because Cilium implements the gateway API. You can use the Cilium as the gateway to route the traffic. For example, if the URI is full, I can use the Cilium to route the traffic to some services. And the bar, I can route it to another services. On the right left side, right bottom side, you can see you can do the canary deployment with Cilium. Like you can say, I want to 99% of the traffic going to echo 1, and the last 1% going to echo 2. And that's how you can use like the Cilium to do the canary deployment. On top of that, actually, you can see the gateway API spec can also do more now. Like that's the project called GAM. It's called Gateway API for Service Mesh. On the right side, it's very similar. The difference is actually we can attach those gateway API stuff, not only to the gateway, but to the services. And from the diagram, you can see the client is not the external client anymore. Actually, it's from a pod. So from there, you can use the Cilium Gateway API to manage the traffic, not only for gateway, but also for your service, like the east-west traffic. You can still do like the HTTP routing and or doing the canary deploy to distribute the traffic between different services or the versions. Another common requirements regarding the encryption, and a lot of people will think about the TLS or mutual TLS, maybe through the HTTP. And with Cilium, actually, there are a feature called transparent encryption. And there are two models of the transparent encryption. One is called ACISAC, the other one is called WireGuard. We can just leverage like this two encryption to encrypt the traffic where you have minimal management overhead because Cilium will just do that for you on the kernel. And from the preference perspective, usually we recommend the WireGuard because it's newer and it's easier, is better. On the diagram, it's pretty clear. Actually, because we are managing the networking for you, when your traffic leaves the pods, getting to the Kubernetes nodes, we will reroute your traffic to the Cilium WireGuard interface. From this interface, we'll start to encrypt the traffic for you. So on the actual networking side, actually the traffic is encrypted, and on the receiver side, we reroute the traffic to the WireGuard, and the WireGuard decrypt the traffic and forward it to your receiver. So the next one is a very common one for like a zero trust. How do I make sure the pod only gets the least privilege permission? And usually if you use other solution, usually you will need two like policy engine. One is for the Kubernetes network policy, and another one maybe for the layer 7 engines. But with Cilium, actually, you can do that with Cilium once. For the Kubernetes network policy engine, it's a Kubernetes standard API. AWS CNI supported, but it has its own limitation. The limitation is you can only do that for layer 3 or layer 4. That means the policy you're configuring here is can pod A talk to pod B on port 3, on port C. The Cilium network policy is a new CRD where you can have more granular control. For the same requirements, Cilium can do pod A talk to pod B on port C using HTTP GET for this URI where you can have more protection for your API. So if we do that side-by-side comparison, like it's the same network policy. On the left side, it's a standard network policy. On the right side, it's a Cilium network policy. The only big difference is here where you can have the rule saying this is the HTTP traffic, I only allow the HTTP action for GET, and the path is the API v1 and for products. Okay. And the last but not least is when things goes wrong, how do I observe the traffic to do some sort of troubleshooting? And in many cases, without Cilium, you probably have to use the TCP dump to check like the traffic port by port to know where this goes wrong. But with Cilium, let's see what you can have. So Cilium actually offer you another component, Hubble. It has a CLI, it has the HTTP GUI. From here, you actually can see the service map. You can have a good understanding of your Kubernetes service, how they call each other. And beyond that, you actually can see the layer 7 information. I'm not sure this is too small, but you actually can see this is the HTTP post to certain URI. Let's put things together. So I think from here, we have a clear answer for this sort of common requirements. You can use Cilium to do everything, almost everything. Canary deployment, you can do the gateway API. For the encryption, you can use the WireGuard. For the network policy, you can have the Cilium network policy from layer 3 to layer 7. And to observe all your traffic, you can have the Cilium Hubble. Okay, so not sure if you are very familiar with this application. This is a very common sample application from Istio. It's called Bookstore. So it's pretty straightforward. When the traffic receives the product page, it's gonna random pick one of the review, and let's say V1, V2, V3. And when you select when the traffic hits the V2 and the V3, it will try to get the ratings from another service, and also it has the details. This is gonna be our demo app. Any questions before I go into the demo? Okay. So this is the demo app. Like when I refresh, you should be able to see like the review are changing because that's randomly picking between V1, V2, V3. Sometimes it can be red, black, or none. Like the V2 is the black one. On this side, I'm gonna show you what the configuration looks like. So first, on the Kubernetes side, you can see my my deployment. This is too small. Let me zoom in a bit. So this is the application we're talking about. I have a product page and a landing page, and it has 3 versions of reviews and 1 rating and 1 details. And for the actual Cilium config, let me zoom in here. So it's pretty straightforward. And you enable the E9 mode to let the Cilium to take care of everything. You enable the gateway API, so we can use the gateway API. And all you need to do for the encryption is just enable the true and type as the WireGuard. We want to use the WireGuard to do the encryption, and we enable the Hubble. The other are more like some configuration that you don't need to care too much. So as you can see, you can access these applications, what we did here. So actually the configuration that right now we are having is this gateway application. So we configure the gateway, we expose that through port 80. And on the gateway, what we're saying is we attach this HTTP route to the gateway. And when the traffic is to the root, we will route the traffic to the product page. And for those configurations, when you deploy that on the EKS, like EKS will, provision a load balancer for you. So here is the load balancer. Actually, it's the URI we're accessing here. And we're accessing, I'm not sure if it's too small. So from here, you still cannot see the URI. But here it redirected to the product page to see all the pages. So the next thing we're gonna do is we're gonna try to do like the canary deployment for the east-west traffic. So when you hit when the product page hit the review, it always goes to version 2. So here is actually the configuration and pretty straightforward as you can see here. So in this time, we are attaching this HTTP route not to the gateway anymore, but to a service. And what we're saying here is we would like to only forward this traffic to the reviews. In this case, it's a review version 2. Let me do. As we configure here, we can refresh the browser again. So as you can see, no matter how much time I refresh, it always goes to the version 2. Okay, so the next one is the network policy. So this is the network policy I'm gonna apply. So for the product page, we'll only allow the traffic from the ingress. And for the egress direction, we'll only allow the traffic going to the details. And for this URI, doing the HTTP GET. Very similar thing for the detail, we only allow the traffic from the product page. And for the review, we only allow the traffic from product page. And doing this like review services. On the rating, we only allow the traffic to access, this is for review, it only allow the traffic going out to the ratings. On the ratings, we only allow the traffic from the reviews. And last not least is actually because we start to implement the network policy and all the traffic within the cluster will start being dropped. So the first very important network policy we're having with Cilium is allowing the traffic for the DNS. And for the Cilium network policy DNS, we actually can see more. And we can see the actual the DNS query. Let me apply the network policy and to see how that looks like. Okay, I have applied all the policies. And everything's working. Sometimes you even don't know if that works or not. We'll check out that later. If that's because of network policy is working or nothing works, we'll figure out that later. But when we are doing all of this, when something's not working, how do we see that it's not working? That's where the Hubble shows. And in this case, let's use Hubble CLI to see the traffic that we're seeing through Hubble. What we're doing here is we're using Hubble to follow the traffic for the default namespace. Sorry, let me do the port forwarding first. Okay, let's refresh. Well, that's a lot. So from here, you actually can see the full traffic flow. So at the very first beginning, we're seeing the traffic from the ingress to the product page, something like this. And from the product page, you actually can see the traffic from product page querying the core DNS. On top of the port 80, you actually can see the traffic is querying the DNS for detailed services for IPv6 and IPv4. And we are also can see the actual DNS query replying the IP address of that services. And after that, you can see because we have the network policy, the policy allowing the traffic from the product page to the detailed services. And from here, because we have a HTTP layer 7 network policy, you actually can see the HTTP request the product page is trying to do a HTTP GET for this URI. And in this case, traffic getting allowed, and a similar thing for the review to rating, and all of the things here. Okay, so you may ask, like, if nothing works, like that should, like, you are seeing the same result. I just don't know if that's the policy you're working or it's not working at all. So in this case, let's remove like one character here. So it's not called ratings, it's called rating. Let's reapply the policy. So as you can see, nothing changes. The only one is the one we're allowing the rating services. And when we refresh, you actually can see the rating services are not available. That's because we only allow rating, not ratings, and our actual API call is ratings. If we check the traffic from the hubble, you actually can see this one. When the traffic from the review to ratings, traffic got dropped for this one, for this URI, because we're allowing the ratings, we're allowing rating, but the actual calling is actually called ratings. And that's the demo for the network policy. The last one is the encryption. You can see everything is just working. And how do I know it's got encrypted? We actually can see that through the interface. We're doing a TCP cap on the TCP dump on the Cilium WireGuard interface. So when we refresh, you actually can see some of the traffic going through here. I have to admit that the user experience is not very good, because you still have to figure out what this IP really means. But right now you can still see this is kind of a proof. Like this is accessing 9080 because of all our microservices are using for the 9080s. So you can see the traffic between the microservices are going through the WireGuard. That means the traffic are encrypted. So to summarize it, so you can see for those kind of a common requirements, you don't have to use too many tools. Like the Cilium itself providing you the networking and gateway API encryption, authorization, and observabilities. And that's everything for today. And the other time is for Q&A. Okay.
You have a GUI for Hubble, or is it the CLI?
Here is the UI for the Hubble. And there are two versions. And you can use the CLI, you can also use the UI. It's just like it's the same services, you just have two interfaces.
And how does it send to the GUI? Like you have to send it out.
Give me 1 second. So if you look at the Kubernetes namespace, right, the kubesystem namespace, there is a pod called Hubble Relay. So every Cilium every Cilium pod will forward the traffic to the Hubble Relay. So from the Hubble Relay, you can choose to use the Hubble CLI to receive the traffic from the Hubble Relay, or you can have a GUI to connect it to the Hubble Relay.
So the Hubble relay is the place receiving the traffic from the whole cluster, and it's about when it's up to you to see that traffic in the CLI or the UI. Okay.
Yeah, the UI, is it populating the graph that you see there from all the manifests, or is that only happening as traffic's flowing through the relay?
Yeah, it's through the traffic, not through the manifest. So that means that you can have your real service map based on the flow, not like assumptions based on your manifest.
But there was, if I just install Cilium, straight away install a bunch of different rules, until there's traffic flowing between my pods or to my ingress, I would have an empty UI.
No, actually, in most of the cases, you usually can see the traffic going to the external. In that case, usually the external can be the API server or the traffic hitting the core DNS or the DNS premise. And also, like another good feature of the Hubble is because the Hubble can see your traffic. So, like Hubble actually, actually in the enterprise version, Hubble can create the network policy based on the flow A observer. Any other questions? Okay, that's fine.
I saw you were doing HTTP for all of your ingress.
Yeah.
Will it work with, Elastic Load Balancer and provision TLS certificate if you give it a DNS name?
That still works. For that part, when you say it still works, I think it depends on what still works. For example, if we're talking about if you have all HTTPS traffic within your cluster between pod to pod, you still can see that, but you will have to deploy like a kind of a middleman attack to decrypt your HTTPS traffic. That's for sure. The UI, like right now it's not boot up, like it's just a fake picture.
How would you boot
We
up?
have another helm, and let me see. I think I can do this like with the CLI here. Let me check it quickly. So, no. So, like, you still have to deploy one more pod. From there, you will be able to have another pod receiving the traffic from the relay. That should be pretty straightforward here. And I don't remember the actual configuration, but you should be just like configure something like this. UI enabled, something like this. That should be it. Because the UI is just one more pod. All the architecture are there. Okay. Can you also send these metrics to Grafana or Okay, I think it's better for me to show you another picture. Give me 1 second. Okay, so actually this is another one I didn't show that one in this section, but this is like the Hubble's architecture. So as you can see, every Cilium node has the Hubble component and it has the metrics. You can use your Grafana and your promises and Grafana to script the metrics, and we have the gRPC on the Hubble between the relay and the Hubble component on Cinnamon node. That's how Hubble relay receive the traffic. On the right side, it's up to you to forward that traffic from the Hubble relay to the Hubble UI or the Hubble CLI. Hopefully this diagram give you a better, clear picture. Okay, I think that's everything from me.
All right, thanks for the presentation. Now we have some giveaway quiz. So please scan the QR code and join it with your username. It's pretty simple. We have some 8 or 10 questions, multiple choice based, and the faster and the quicker with the right option you select, you get a chance to be up on the leaderboard. And top 3 on the leaderboard gets Code Cloud subscription for 6 months. So yeah, wait for a couple of more minutes and then we'll start. And we still have some pepperoni pizzas outside, so feel free to take it away with you and enjoy it if you want it now. You might not see much on this screen because I'm yet to start the portal, but just keep the QR code scanned and add your username if it asks. It will now. Yeah, if you click on join quiz, it will ask the username now. I see people joining in the leaderboard, so we are good to go. I'll still wait for a couple of more minutes. Bless you. All right, looks like we have everyone joined. I'm gonna start. What powers Cilium behind the scene? Is it eBPF, generative AI, Argo CD, or Helm charts? The next up, what's the main purpose of using chaining mode of Cilium? To avoid all networking issues for the rest of your life? Reduce YML files, sorry. Easy to set up, or it provides better security? Okay, it is easy to set up than the other mode. For ENI mode, which component does Cilium takes care? Is it security, login, AWS CNI, or all of these above? This is something Lee discussed in the presentation. There you go. The next one. How does Cilium encrypt the traffic? Using AES method, using base64 encoding, IPsec, or Wireshark? I guessed that it's not Wireshark, it's WireGuard.
Yeah.
That was the trap. The next one comes up. How does Cilium improve network policy implementation? By drawing diagrams, blocking all traffic that nobody can access our website, layer 7 filtering, or by replacing kubelet service. That is correct. Cilium enhances gateway API implementation by managing the east-west cluster traffic, replacing ingress controllers, blocking all non-HTTP traffic by default, or redirecting all traffic to someone else's websites. It is A, that's correct. Which component Cilium provides for observability? Is it Grafana, Carpenter, Hubble UI, or CloudWatch? That's Hubble. What's the best way to troubleshoot Cilium networking issues? Restarting the whole cluster and hope everything works fine? Using Hubble trace flows? Deploy a whole new cluster parallelly, or search on Stack Overflow? Well, / ChatGPT nowadays. Why? Isn't restarting is everyone doing for troubleshooting? Well, I do that for sure. The last one, okay. Why eBPF is so crucial for Cilium? It does not require any YML files, or it gives free AWS credits. It provides some kernel level insights, or nobody really knows, but it works fine.
Provocative.
Yeah, that's the answer, I guess, but let's see. All right. I'm with the guy who selected C. That's that's the right. All right, that marks me with the end of this quiz. Let me pull up the leaderboard. So congratulations to all the top 3 people, Ever, Jimin, and Elik. please please stay here after the event and share your contact details so that we can facilitate the giveaways. And with that being said, yes, it's all from our side, a small but intensive meetup once again. And thanks a lot for joining. And that's my time for today. Thank you so much. And we still have some time. So if you want to enjoy the view and talk with other peers, networking, some pizzas out there, we are all welcome. So yeah, thanks for joining and see you next time. Bye-bye.